Hello friends, welcome to the Unacademy, which is the largest online education platform for GATE Computer Science and IT. Myself Malesham Devasai. In this class, I'll be discussing the much and more important topic for exam point of view, that the differences between the LR grammars and LR tables, as well as how to construct them, what is the LR parsing. And if you look at the previous sessions, we have seen about the grammars, how to check the given grammar is LR0, SLR1 or LLR1 or CLR1. We have the various rules to check the conflicts like SR and RR conflicts. Okay, before starting today's session, let me introduce myself if anybody is new to this class, and welcome to everyone guys. And jarur like kar lijiye. It's a very important for us to make the presence in the class. Yes, Sai Sandeep, good evening. Satyajit, good evening. Guys, I have secured GATE All India rank 119 and 210 with self-preparation in my BTech, and then I have completed MTech from IIT Bombay. Almost I have now more than 12 years of teaching experience, and then here I'm teaching TOC compiler programming. And you have a referral code. This is a referral code to get 10% discount, as well as you will get guidance from me to prepare for GATE exam. And there are many special classes that I have taken so far in Unacademy. More than 70 classes I have taken. That is nearly, you can say, 400 hours of content, which is completely free for you. And you can visit unacademy.com/devagatecsc. So this will help you to learn something from me, guys, like mini GATE quizzes, CCTV quizzes, C3 dot quizzes. These all are live classes that I have taken. You can watch recorded, and you can also attend the ongoing live classes too. And C programming, TOC compiler, free classes, as well as algorithms, revision of TOC, CDC programming, and all-in-one series. And you will have practice sessions separately for each subject, and guidance classes for GATE exam, and daily practice problems and doubt solving sessions, and previous year question series also I have already taken. And Vesha, good evening, and Vaibhav, good evening. And if you are interested to prepare GATE seriously, and we recommend to join Plus or Iconic. And what are the benefits of Plus or Iconic subscription? You will have structured courses, well structured, and you will have live interaction with the faculty, and you can clear a lot of your doubts while the class is going on. And all these structured courses are well planned, well organized, and this will guarantee your rank. And to ensure that if you are paying to somebody, you must guarantee your rank. That is the reason we have introduced the Iconic subscription. The Iconic subscription will guarantee your rank. That is, you will have a dedicated coach and live interaction with the educators, and separate study material, and booster session, separate study plan, and personalized test analysis, and this kind of things which will guarantee your rank. So, and apart from this, you will have a Plus subscription, which is already beautiful and which has much content for you, like complete courses, revision, crash, practice, and GATE PYQ, long-term and short-term batches, and test series is also part of the Plus subscription, guys. And if you look at the plans that you have, after applying my referral code DEVALIVE, you have 27,225 for 1 year subscription of Plus, and 34,650 for 1.5 year, and 39,600 for 2 years subscription, guys. And if you look at the Iconic plans, that you have 1 year, 2 years, and 1 year, you have 45,225 after applying DEVALIVE referral code, and use kar lijiye compulsory DEVALIVE, and 66,600 for 2 year Iconic subscription. And you also have the GATE aspirants Facebook group for computer science to get regular updates from us. And this is our old team Telegram channel, where you will get the links of every subject which we are going to take every day, free classes, and that's going to be really beneficial for you guys. And you subscribe to this Telegram channel so that you can follow us. And also, there are so many YouTube channels we have completely free from Unacademy, and please share all these channels: electrical, electronics, mechanical, civil, Telugu, SSG, CSC, and gate questions, electrical junction, Pathshala, and RRB SSC 2. And guys, look at that. We are here to deliver some content which really helps you, like operating system by Khalil sir, and data structure by Vishwadip sir, and C programming by me, and discrete mathematics by Satish sir, and TOC I'm taking here, and probability and that's engineering mathematics by Pallo sir, and then OS by Khalil sir that I already told, and CN by Pankaj sir, digital by Arun sir, and all are going to work for you, and we are trying to connect with you, and please follow us on this channel to learn something from us. Yeah, if you have joined late, and do not forget to like the session, guys, and please like the session and share with your friends, and also do not forget to subscribe. Yeah, let's begin this today's session. In this session, let's see what we have done so far, guys. In syntax analysis, we have learned these 4 grammars, including the top-down parser, as well as what is context-free grammar, ambiguous and ambiguous. And what we are going to do today is how to construct a LR0 table, SLR1, LELR1, LR1 table, and then what are the differences, and how to do the reverse of RMD with the help of this table. So this is the today agenda. Yeah. Yes, Sai Sandeep has a good question. In the previous session that we had, see, we have a CLR1. Today I have a topic as I'll discuss little bit of the concept here. We have a CLR1. Then why do we convert to LELR1? The reason is CLR1 takes more space, and here takes less space because you combine the states, right? But when you have a conflict, then definitely we might have other techniques to handle them. So to avoid this space, that's all we are combining. But CLR1 is a more powerful. If you are not worried about the space, go for CLR1. But today this LELR1 is very popular, even though it is not powerful. The LELR1 is popular because it takes less space, because we combine the states. Indirectly we save the space of the parser. So this is the reason, Sandeep, we take the LELR1 into consideration. Today most of the bottom-up parsers, they use LELR1. Of course, when they get RR conflict, they may not require such kind of structure, so they try to avoid such grammars. Okay, so today most of the programming languages, they are handled by LELR1 because they are going to be taking less space compared to CLR1. All right, now let's move on. Now we need to construct the LR tables. We have 4 types of LR tables: LR0, and SLR1, LELR1, and CLR1. We have 4 tables. And out of these 4 tables, you must be careful. Many things we handled with the same rule. Rules are different, entries are different. Remember that. Rules and entries. We are going to talk about 2 things: rules and second, entries. How to give an entry. Rules will help you how to give an entry. So how to give an entry, we might have the same rule, but the entries might change, depends on the table. So now let's talk about, I have the types of entries. Shift entries. So who is responsible for this? Shift items, but not directly, indirectly. State entries, we will have state items, somehow they are going to give entry of that. Accept entry is a very special. S dash to S dot is that item is going to be responsible for giving an acceptance entry. And this one, any production, we have the completed one that is responsible. Blank entry which are left, the blank entries of the table we can call as error entries. Whichever left, we have not given any entry into the table, that means blank. It's called as error entry. So we'll try to learn one by one. We'll try to learn one by one, then we'll understand each one slowly. Guys, first, what is the shift entry of any LR table? The rule is the same for all parser. The rule is same. Shift entry rule. Shift entry rule is the same for every LR parser. For all LR tables. Like LR0, SLR1, LELR1, CLR1, doesn't matter which parser you are following. The rule is same, but number of entries may differ, depends on your diagram. Depends. And when you look at this shift entry for LR tables, every terminal transition of the diagram will give one shift entry in the table. In table, guys. So if I have, let's say 10 terminal transitions, then you will have 10 shift entries. So each shift entry, if anybody asks how many shift entries are in the table, then just look for diagram, number of terminal transitions in your DFA. So this principle is same for all LR tables. Whether it is LR0, SLR1, anything, doesn't matter to us. Yeah, good evening, good evening. Is that clear? So how to give an entry, we don't know. But first learn the theory, how you will understand in future, guys. The shift entry, nothing but terminal transition of the diagram, is going to give a shift entry in the table. Just all you need to map. Is it clear? That if I'm going to ask you, okay, let's look at it. I have something like, I have a state, let's say I5, and from here, let's say on small a, I'm going to I7. Then you are going to give one shift entry for this, guys. How? Just look at this. The fifth row, this is a row, guys. Row 5, and under A, you are going to say 7, but this is a shift 7. So S7 we are going to write. Look at that. I have a terminal transition so that I will get a shift entry for in the table. Is it clear? Is it clear, everybody? This rule is same for everyone. LR0, SLR1, everybody follow this rule. Everybody. And this rule is applicable for all parsers. I'm saying it. Applicable for LR0, SLR1, LELR1 and CLR1. Clear this point? And the first point, when you are going to talk about this, the number of shift entries, you can keep that note yourself. Number of shift entries for the same grammar I am talking about of LR0 table is equal to number of shift entries in SLR1 is equal to number of shift entries in LALR1. Then how this is related with CLR1? CLR1 may have more or equal to this. And this all are less than or equal to the number of shift entries of CLR1. So this is the first principle that you should remember, and while drawing it we will see it. While drawing we will see it, guys. Let's move on. State entries are similar. Every non-terminal transition, that's example, you have I6. Suppose you have capital A, you are going to I9. State 9. Then you will have an entry like this. Okay, 6. Under A, you will have 9. Now you don't write S9. That is a shift entry. State entry will just give a number. This is the row. And A is the column, of course. And this is an entry. Entry will give just state number. Clear? Yeah, good evening, Nishu. State number. And this rule is also same for all LR0, SLR1, LELR1, CLR1. This rule is also same. And if anybody asks the number of state entries, and if you look at number of state entries for LR0, SLR1, LELR1 is same. Only in CLR1 you may have more or less, because of CLR1 diagram could be bigger, right? But LELR1, when you combine, you will get equal to the LR0, SLR1 number of states. Okay, now let's move on. Come to, and remember this point. And guys, acceptance entry everywhere same. Suppose you have a state, in that you have somewhere s dash derives s dot, and others you may have, we don't care. And assume this state name is, let's say, let's say I. Then you go to I, row I, under dollar, you just make accept. This is a very special entry for us in whole table, right? This is the common for all LR tables. Yes. Clear this point? This is the acceptance item. Remember that? Do not call this as a reduced item, even though it is a completed but very special reduced item. So we call this as acceptance item. I have a name for this, acceptance item, so that we will have an acceptance entry for this production, And now if you look at this, is same for all LR parsers. Now this reduced entry is going to differ because the follower's power is different from one parser to other parser. LR0, SLR1, LALR1, CLR1. Before entering, guys, look at the history of all the parsers. LR0, SLR1, LALR1 and CLR1. And if you look at the follow, the power, whenever the item is reduced, it has no power. Here we don't look at followers here. We don't know who is next. That's look at basically. Here we look at whole grammar. Whenever you want any follow of a non-terminal, we look at whole grammar. We look at followers, no doubt, whole grammar. We look at followers of old grammar, and LELR1 we look at followers, no doubt, but path, followers based on combined paths, because we may combine some of the paths, combined paths. Here we look at canonical means exact. We look at followers based on exact path. We don't combine here. Look at that, how this one is going to be differed here. 0 means we don't look at any follower. 1, we look at the follow of old grammar. Like if suppose capital A production is reduced, let's say this is your production, then we compute follow of A based on a grammar. Follow of A based on a grammar. And LELR1, if suppose A2 alpha dot is there, then we may have T1 or T2. But T1 or T2, maybe you have combined two states. So it's based on, this is the follow. It's based on combined paths. It's a path, no doubt. Sometimes may be combined. And if you have A2 alpha dot comma T1, this is exact path. This follow based on exact path. Based on exact path. Okay guys, so don't worry about much of this exact path or not. We will understand. Yes, we'll understand. Yes, good. Everybody following? Good. So far everything is clear. And guys, don't forget to like the session. And this kind of the content maybe very rarely you see on YouTube. And I hope you are enjoying these classes. And every time I introduce the content, we will have some different content to present. So keep engaging the classes if you are learning from us, and we will bring you the best content in world, of course not world, in India at least. So keep following us. Okay, now how to give reduced entry for LR0. Suppose there is an item I is a state, I is a state, I2, I3, something like that. Let's say example I am writing here. Let's say I2. So I will be connected with example. I2 is my state, and here A2 alpha dot is reduced item. Then other items may be there, but what you have to do, every reduced item in the diagram you have to look at. If there are 10 reduced items in this state, 10 times we have to calculate something, guys. Is that clear? If the state has more than one reduced item, consider each reduced item. So in this, if you have any other reduced item, you must take again. So what I do here, here I'm going to look at, this is called as action part. There are two parts in the table, or you can construct two tables also if you want. Action part, go to part, or action table, go to table. The whole action in the row 2, you are going to write this production. Every column you are going to write this production, like A2 alpha, A2 alpha, A2 alpha. Guys, writing the production is too difficult. So what we do here, we number it. In the grammar, we may number it. Let's say this production number, let's say 3. Number 3. So you can write simply R3. Instead of writing whole production, you can say R3. That production 3 is reduced. Is that clear? So production 3 is used for the reduction. Yeah, everybody. So look at, either you give production or you give the number of the production. But number of the state is different, number of the production is different. So I have a clarity. Yes, numbering of the production. Either you write whole production, but whole production takes space, so you can write simply R3. That's a good idea. Okay, now let's start doing it, guys. Doing it. How do you make an entry into the table? Now, guys, we have a grammar. So I have a quick construction. Everybody knows how to construct, so I'm trying to do it very quickly, as you know it. And here you will have A derives dot A. Why you have not taken capital B? Because capital B is not there just after the dot. So remember, and S dot, and here capital A, so that you have S derives A dot B. And now you have to take all the B productions, because B is there just after the D, after the dot, after the dot. And A you have to read A derives A dot, and here you have to read capital B. So S derives. We have already have good practice how to construct the diagram, how to draw the diagram. Now using this diagram only table, guys. This diagram only table. So I'm numbering it to have an easy 0, 1. This is a 2 and a 3, 4, 5. How many rows we should have? How many rows, guys? We should have 6 rows, 0 to 5. Clear? So every row is nothing but we are looking at a state. So state correspond to row. State correspond to row. Clear this point? Everybody? Come on. 6 rows and columns, guys. Here we have some barrier. This is actually not a one table. These are actually two tables, guys. Two tables. One table is called as action table. This is called as action table. And this is called as a go-to table. Action table, go-to table. So we can combine the two tables, not a problem. And you can assume it is a one table. And here in the action table, we have only terminals like small a, small b, and dollar. These are having terminals which will correspond to action, and go to correspond to non-terminals. We have 3 non-terminals, right? So 3 columns. Yes, action part, the correspond to the rows versus terminals, and go to table correspond to the rows, nothing but number of states, correspond to number of non-terminals. Yeah, correct. Yes, go to table, action table, we can mix up. Now one by one, guys, focus on shift entries now. If you look at the shift entries, means you have a terminal transitions, small a and small b. That's all. We have 2 terminal transitions. Can you see that? You have 2 terminal transitions. You can see that. 2 terminal transitions. So I'll keep on writing. I'll delete immediately, guys. So we have like from 0 state, by reading A, we are going to 3. What is the meaning of that? What is the meaning of that, guys? So 0 row under A, we are going to write as 3. Is that clear? Why did I give that entry? Yes. Next quick. Now look at that state 2. State 2, by reading small b, we are going to state 5. Look at in the diagram, row 2, we are going to give under b, we are going to write S5, because we are going to state 5. So this is about the shift entries. I have 2 terminal transitions, so 2 shift entries. So no confusion at all, everybody? Yes. Clear, good. Now state entries, shift entries are over. Now go to the state entries. How many state entries are there, guys? One is S, other is A, other is B, and total 3 non-terminal transitions. So one by one. First one, from 0, by reading S, we are going to 1. So 0 under S, I will give 1. 1 is a state number. Go to entry, also called as state entry. Go to entry, also called as state entry, guys. Next, you look at from 0, by reading non-terminal A, we are going to 2. That is 0 under A, we will have a 2. That's all. Now keep on doing that. Next one. From state 2, by reading capital B, we are going to state 4. Means 2 under B, we have a capital 4. So total 3 non-terminal transitions, we will have 3 go to entries. Clear, everybody? Yes, that's all. We have shift and state entries. And this is the same for LR0, SLR1 and LLR1, guys. If you draw the LLR1 table, these entries will never change. So I'm just I'm going to do copy paste of SLR1, guys. In SLR1, these entries will not affect. Not only this, acceptance entry, acceptance entry. Can you see that? That in 1, you have S dash to S dot. That means on row 1 under dollar, we will say accept. Yeah, this rule is also same for all LR parsers. Yes. Now we have completed almost, guys. One thing is missing, reduced entries. Now how to give reduced entries? This is one of the difficult concept in all the LR tables. Why? You have to look at every reduced item in every state. If one state has 10 reduced items, 10 times you have to calculate for one state, guys. Now don't look at outside the state, look inside the state. Is it reduced item? No. Yes, but it is an acceptance item, we don't consider. And is it reduced item? No. Yes, we have, this is reduced item. A derives A dot. Now go there. A derives A dot. Now I have already numbered, that is a state 2. Can you see that? Production number 2. I have numbered it already. And A to A dot present in state 3. And guys, row 3, we are going to give a special entry that is called as R2. Why are you giving to entire row? Because I don't have the power of follower. I can't see who is my next follower. So what I do is, in entire action row, I'm going to say my production number 2 is reduced. Yes, everybody, R2 means A to A is going to be used in the reduction. Clear this point? Now guys, it's not over yet. Only one item we have seen it. And look at that next. Oh, this is also reduced item. So that means again the same concept. This item is reduced. That item number is 1. The production number is 1. That is there in the state 4. So row 4 we are going to write as R1. R1 can be used for the reduction. But you are not able to understand who is going to be the next terminal because you don't have the cover up of computation power for follow set. Next. Clear this point? Next. And did you look at every item? Not it. And still this is there. Okay, B to B dot. The production number is a 3. 3 is a production number. Look at your numbering. You have already numbering. These are production numbers. Okay, now this is there in the state 5. So row 5, we are going to say R3 is reduced. That's production 3 is reduced. This is used for reduction. Now guys, now also you can understand conflicts. Do you have any conflict? If you have any conflict in the same cell, you might have seen RR or SR, but you don't have any RR SR conflict. That is the reason this grammar was LR0 grammar. This grammar is LR0 grammar. But this can be understood without considering the table also. In the diagram, we know how to check LR, SR and RR conflicts. Is it clear? So this is also can be done without constructing the table, but in the exam if they ask particularly how many shift entries, diagram can answer. How many state entries, diagram can answer. But how many reduced entries, diagram you may not have a clarity, because the reduced entries doesn't depend on just the diagram, it depends on your knowledge. That is, okay, each row action part you must give that entry. Is it clear? So you must visualize the table, how many entries will be there for the reduction. Okay, yes. So are you ready for SLR1 table? Is it clear, everyone? What is LR0 table? Yeah. So keep if anybody has a confusion, just rewind the video, you will have a clarity. Okay, next one, reduced entry for SLR1. Same, you have to look at every reduced item, but suppose you have an item, suppose guys, let's say x2 alpha dot, the production number, let's say k, and the state number, let's say 3 is the state number. So what do? You must compute follow of x, then only you do something. Suppose you got it answer t1 comma t3, then what you do? You have to go to the table. Which table, which row? 3 row, because the state, and under T1 and under T3, what you have to do? You have to write the production number, that RK is reduced. Our production you can place there. That is how we give. Now entire action we don't give now. Look at the follow set. Look at the follow set of the reduced item. So compute the follow of this X. Compute follow of this X. Previously we don't have the power. Now we need to compute the follow of X. Exactly. Is that clear? K, and remember that you should have a clarity production numbers and state numbers. That is the reason I have used the Roman numbers to understand the production numbers. Okay, now let's move on. Now the same guys, I'm just going very quickly. You know the diagram, everything. Now I don't speak much, but I will keep everything as it is. As if you don't speak, it hardly takes 1 minute time to construct, and just number it properly one by one. 0, 1. Numbering is also your choice. These are the production numbers already given to you, so no confusion. So 0, same grammar, same table, almost no change here at all. And shift and state no change, shift state no change. So 0A3, that is S3, and then we have 2B, that is S5, and state entries 0S1 and 0A2 and 2B4. Yes, and now we have the reduced. Guys, better to compute the follow set first, so that every time no need to compute. So I will compute first, guys, to have a clarity what I am going to do. Is that clear? So keep somewhere follow set, follow of S, compute just $. And what is the follow of A? Is the first of B, that is a small b, and follow of B, capital B, same as the follow of S, that is a $. So I computed it, because I don't worry every time what is this follow. Now look at, you have to look at this one, you have to look at this one, you have to look at this one. Only 3 tick marks now. Remaining, you know, the S dash derives S dot, that is accept. That is accept. Don't worry much about it. Okay, now start doing it, guys. Here we look at follow of capital A. We know that is a small b already. So row 3 under B, the production number is a 2. Row 3 under B, we write R2. 2 is the production number. Remember, A derives A is a number 2, production number 2. Next, B derives B dot. I am going for this one. That is the 5th row. That follow of B, we know already $. follow of capital B, we know dollar. So row 5 under dollar we write R3, that is a production number. Everybody? Yes. Next, S derives AB, just you know that already. Follow of S is just dollar. So under dollar we write R1. So row 4 under dollar we write R1. Clear? That's all. That's all we have. This is the SLR1 table, guys. If you look at LR0 SLR1, the number of reduced entries may be less than LR0. If you ask me, can you relate? Can you relate the for the same grammar number of reduced entries of LR0 table will be more than or equal to number of reduced entries of SLR1 table. The reason is because SLR1 will look at the specific followers based on the grammar, but LR0 has no power. That's why in the table when you look at the shift entries, state entries are same, but only reduced entries here more, so less number of blanks. Sorry guys. And here, everybody clear this point? Yeah. Here we have less number of reduced entries, so you may have more error entries. Guys. So error entries also related to this reduced entries now somehow. More blanks compared to that. Okay, now move on to the next one. Reduced entry of LR1, LR1 is so easy now because here if you have x derives alpha dot, here you already computed something like T1 comma T3. Are you clear this point? You already have it. So what do you have in the table? If I assume this production number K and state number I, so row I under T1 under T3 you are going to write RK directly because you have already followers. So look at these columns. So under this columns, under this terminals only we give an entry. We don't compute follow of X additionally because already computed. As I look at portion, it's so easy, but problem is the construction of the diagram takes time here because every time you have to compute the look ahead, and for LR1 again it takes more time because you need to club the states when you have the common items. So you may have a more number of look aheads here because you combine them. Is it clear? And sometimes LR1 and LR1 diagram may be same when all states are different, like this example. This example, for both of them you will get a same table. So look at the construction of the diagram, guys. Same diagram, but approach is different. S dot, but we write a dollar, and S derives dot AB comma dollar, and now A only we write, but dot A, its follower depends on this A. After you have a capital B, so capital B gives small b. So that is important, guys. That computation takes much time now. Now here S, just copy paste but move the dot. Clear? Yes. And then if you read A, just move it. Don't compute anything now. After writing this, write capital B productions, then compute capital B follower. After capital B, nobody there, so dollar paste. And when you read A, just move it, dot, move the dot. Don't do anything now. And here also B, copy paste, move the dot. And this is LR1 diagram as well as LE LR1 because all the states are distinct. So here this grammar is both LE LR1 as well as this is LE LR1 and LR and CLR1. Remember that. This DFA is both diagrams. Now we have no conflict in both of them, no doubt. Now how to consider the table, that I am trying to help you guys quickly. So again same, number it 0, 1, 2, 3, 4. Did I miss somebody? Yes, one state is missing, guys. This one on B is missing. S derives AB dot comma dollar. Okay, I'm numbering it 4 and 5. So same using this one, I have 6 rows 0 to 5 and same terminals AB dollar and go to table that has SAB, and remember both actually different tables we kept in same table to save our time and space. Okay, now shift entries rule is same. If the CLR1 diagram is bigger, then you may have more entries in that table. So CLR1 table, LLR1 table, don't assume they are always same, because sometimes when you merge the two states, indirectly you will merge the two rows. So after considering the table also, you can copy paste to get LLR1 table, because LLR1 table will be possible if you merge the two rows of LR1. So sometimes you can consider the LLR1 table with the help of LR1 table too. Yeah. No, procedure is same, whether it is null production or not null production, answer is same, right? You just look at the followers, whether epsilon or not, you need to compute the follower. Don't forget, you need to compute the follower for every production. Okay, start doing it. 0 on A, you have 0 on A. I'm doing this, guys. S3 same, and 2 on B, S5. Shift entries you got same because of LLR1, and 0 on S1, 0 on A2, and 2 on B, capital B, 4. And this looks like same, but sometimes CLR1 may have a bigger table. That's why more shift entries, more state entries might be possible in CLR1. But LLR1 you will get the same as the previous two. Next, reduced entries. Here is different. Now go to the this one, and then this one and this one. Their reduced item is there. So what you do, accept also you keep first, guys. 1 comma dollar accept. That's common everyone. Now start giving entry, guys. This one. Here B is there. So under B you have the production 2. In row 3 under B you have a production 2. Okay. Already this grammar was LR0, guys, so don't worry much about it. And next, under dollar, because dollar already there. Dollar, look at this one. Dollar already there. So under dollar you will have the row 5. You will have the production number is R3. 1, 2, 3. And this looks like same as SLR1 because the grammar was already SLR1. And this one is derives AB under dollar. Row 4 you will have R1. So this is a LR1 table and CLR1 table, and definitely this could be different from sometimes SLR1, and LR1 CLR1 sometimes can be different table because some two rows can be combined into single row. Yes. Nishu, error entries, Carole, and have you understood the LL1 table? The blank entries will help you during the parsing syntax error. And you want 2 on A, you don't have anything, so you can't take any action. So that will correspond to syntax error. So blank entries will produce the syntax error while parsing. You wanted these entries, but these entries are called as error entries. All the blank entries will correspond to error entries. These are going to help you during the parsing. If anybody wants this blank, and it will produce syntax error because this blank corresponds to nothing. Everybody? So in all the tables, all the blank entries are correspond to error entries, guys. Okay, come on. Now guys, let's move on. And before starting something here, and guys, if anybody not aware of this plus and know about this plus has a lot of good benefits, guys. Lot of varieties you have. You will have live class of not my classes, guys. Every educator on Unacademy, you are free to attend. Only you need to take the subscription. You may use my referral code or anybody else, but once you come to the Unacademy, you can attend anybody class, and just you need to decide which course you want to follow. And there is no limitation how many times you wanted to learn one subject. It is your choice. There is no limitation of any lecture. You can listen hundreds of times the same lecture. And live classes you can always attend from any educator of any course in the same segment, GATE segment. Okay, crash courses, you have weekly test. Every week you will be tested with one weekly test, and weekend, that is basically on Sunday, and doubt solving session on every fourth day, and English and Hindi classes, rank improvement batches, so many. I'm only giving a few things here. Iconic, all the benefits of the plus. Plus is absolutely great, but those people who are not having the confidence and they want to guarantee the gate rank or any other exam you are preparing, then definitely Iconic is going to help you. You will have a guide, you will have live interaction with the educators personally. It's not within the class, guys. Personally you can interact with the educator to talk about your doubts and all these things, and you'll have a study planner, you will have a booster session, you will have personalized test analysis, you will have a separate study material, and this is going to guarantee your rank. And now guys, now we have the entries of LR table. Let me tell you again. Shift entries. Rule is same for all, but entries, number of entries same for only first three. If you are taking the same grammar, number of entries of LR0, SLR1 and LELR1 will be same. Only CLR1 may have a more. And shift entries, same concept. Shift and rule is same. Accept entry, same. And reduced entry, rule is different for all. Everybody will follow different rule. And entries also can differ. Entries also may differ. Sometimes may be same. Number of entries may differ. But how do they differ? Like this. Number of reduced entries of LR0 you will have greater than or equal to. Opposite, guys. Previously they are equal in shift and state, but here greater than or equal. The number of reduced entries of SLR1, because it will reduce some of them, because you will follow particular you will follow the grammar, you will follow the paths in LELR1. Number of reduced entries in LELR1, and this is definitely greater than or equal to sometimes. Don't forget that. I'm not saying greater, sometimes equal also. Entries in LR1, LR means CLR. So this is how we have the relations, guys. Clear this point? And blank entries, obviously it's going to depend on how many, what is the table size, and how many reduced entries. Okay, so blank entries remaining, whatever left, it's going to be blank entries, also called as error entries. Okay, now let's look at comparison of LR parsers. Because of this, the LR0 parser is less powerful than SLR1 parser, is less powerful than LELR1 parser, is less powerful than CLR1 parser. This is power of the parsers, expressive power of the parsers. What is the expressive power? Because if I use LR0 parser, I can only understand LR0 grammars, but SLR1 grammars are more in terms of number of SLR1 grammars. You will have a bigger class, and this relation indirectly it's like this: set of LR0 CFGs is inside set of SLR1 CFGs, inside the set of, these are the grammars, LR1 CFGs, inside set of CLR1 CFGs. And this is about the grammars relation. Every LR0 I can call SLR1, and all the LR0s are in one class. That class is inside the SLR1 class. And when you look at the table, size of LR0 table for a particular grammar is equal to, for a particular grammar, we are talking about for a particular grammar, remember that, for particular grammar. And size of SLR1 table will be same. Only entries will be different, guys. Sometimes that is also reduced entries. Size of LR1 table, and this is less than or equal to, theoretically I am talking about, practically we can decide how do we implement. And if you look at number of states in the diagram, number of states of LR0 obviously equal to number of states of SLR1 for the particular grammar. Again here number of states of LELR1 is less than or equal to the number of states of CLR1. The size indirectly depends on your states of the graph. Yes, CLR1 is most powerful because CLR1 can understand more structures, right? But who is more popular? The LELR1 is more popular. This is a more popular. This is a more powerful. Today, the most of the programming languages, they use LELR1. Today, most of programming syntax oriented, most of programming languages like C, C++, Java, such things, they use LELR1. Is it clear? Today most of the programming languages uses LELR1 as the parser inside the compiler. All right, now I have LR parsing I want to build, guys. You know it, the concept. We have input here. This is our input, and we need to build algorithm, and we should use this stack to understand, and we must have a table. We have already built that we have it, and you decide which table you want to use, LR0 or SLR1 or LELR1, because the algorithm is same for all. It is same for all LR parsers. For all LR parsers. That's the reverse of RMD. Only table will change. Algorithm is same for all, guys. So now assume that you are going to take some table. Now how to scan this with the help of reverse of RMD algorithm. Now this is LR parsing, guys. Here look at, this is some table. Don't worry which table it is. Is it LR0 table or SLR1, LELR1, CLR1, doesn't matter. We have already built a table. Now we are implementing the parser. If I use CLR1 table, my parser name is CLR1 parser, but algorithm is same. Everyone, guys. So we have we are going to build now. We are going to verify the how to verify given input. How to verify the syntax of your program. Syntax of given program. Given program, nothing but given input. Program only we call input string. Our whole program is converted as input string. Just it looks like the sequence of tokens, just looks like a string now. Okay, whole program converted into one string now. Now how to verify the syntax? Suppose I am going to write a program. That program name is, let's say, ID plus ID. Yes, possible. ID plus ID is input. Then how do you verify my program? This is a valid program as per the grammar, but how to use the table? How to use the table to verify the input with the help of reverse of RMD, guys. So for that, you require to understand there are actions. What is a shift action? What is a shift action? And what is a reduced action? Error accept. We are going to understand. Shift action means you got an entry in the table. Assume table name is M. Inside the M, you are looking for something, let's say 0, ID. It's just like S5. And why are you looking at this? Because you might have somewhere 0 is there, and input you might be pointing to ID. So that's why we are looking for 0, ID. So 0 is actually top of the stack. ID is your input. Then you are going for entry shift action. Shift entry. That is S5. Then what do? The first point, shift, whenever you encounter, you will push input. Input is id. Push input onto the stack. Second, push 5 is the next state number onto the stack. So two things we are going to do. Shift action, guys. In general, shift action, you will get something like that. I comma the input. Okay, just let me change this. This is the top of the stack and this is the input symbol. You will get some product, some action like say S and S N. Then what do you do? First operation is push input, and second push N, and push input and immediately increment pointer to the next symbol because we remembered it. Okay, this is going to be your algorithm, guys. Shift algorithm, because whenever I want to do the shift, this is going to be done. This is going to be done every time we do push operations, because along with your symbol there is always a next state number. Next state number. And there is one more going to come, which is really complicated one, and I'm deleting that now. Okay, what is that? Reduced, guys. There is another one. Second one is the reduced action, which is a purely complicated one. Reduction, reduced action. We are going to perform. It's a kind of reduction now. And what kind of reduction it is? M of something like, your take one example, S2 comma plus. You may enter with R2. R2 is actually looks like a production like this one. You can see that R2 means E derives T. This number is also looks like it's not a Roman number now. It's nothing but this E to T. What is the meaning of that, guys? First one, pop LHS. That's a pop top of the stack. That is a pop pop E. And second, push RHS. RHS is a T. But 3, there is something we are going to, reverse. I'm sorry. Sometimes I do mistakes, guys. What I'm doing here is, here reverse of RMD, right? I'm going for top down parser. Pop RHS. But RHS, we can't pop here. There is a problem. That's what I'm talking about. Let me give you a clarity what is exactly it is. Okay. Now let's focus on this. Why it's not easy. Now you are going for the table. What was that? 2 comma plus. You got something is R2. And maybe this one is E derives T. E derives T. So what is the meaning of that? On the table, on the stack, you have T somehow. And above T, you have a 2. And then on input, you are pointing to plus. So what do you get here is, you need to perform reduced. So this T, this is completely need to be deleted. We need to replace with LHS. So first operation is pop RHS. I was doing actually LHS wrong. Pop RHS, but how do you do that? Directly you can't do it. So RHS is wrong. Pop 2 times of RHS symbol, because every symbol along with there is a next state number. Pop 2 times of RHS, then push LHS, and not over, guys. This will be deleted and E will be pushed. There could be some number here, K. So you need to push. There is one more. Push M of K comma plus K comma E. K comma E. This is the go-to entry. Because non-terminal you have to look at. This is the go-to entry, guys. Go-to entry is used internal to the reduction process. Remember that. Every time we push, 2 times we push. Because one is actual symbol, second is a next state number. Every time we pop, we also pop 2 times of the requirement. So this is one of the difficult point for many people. That's why they don't worry about the reverse of RMD algorithm, guys. So practically for GATE exam, I don't think they will ask, but you should have an idea how to understand. So let me do it, you will get an idea. Let me do it, you will get an idea. Accept, I will tell you at the end. Accept. Okay, while doing this, you must come to this position. Then we $1 $, when you encounter, that is accept. So here I'm going to write the reduction process, guys. Whenever you want to perform reduced action, shift action, very easy because you don't have much job. Here it happens m of top comma input, you will get some RK. So what do you do? RK, first operation is pop 2 times of RHS of the production. It's just like RK, nothing but X derives alpha. This is 2 times of alpha. And second, push LHS, that is nothing but X. Third, push, you need to go to the table and look at below X, who is there? Comma X. That symbol you have to push, and this is really important, and you can't remember if you don't look at algorithm. So let's look at the process of algorithm, then it's easy for you. Let's do it, guys. Let's do it. I'm going to do this one. Okay, now let's do one by one step. And we have an input. I have an input here. Input I'm taking as very simple, ID plus ID. So now I'm starting, guys. Step 1. Step 1. Okay, step 1. First I have I'm pointing to ID. So somewhere I need to point out all the time. I'll do that. So I need to do carefully. Okay, now I'm pointing to this one, ID. I'm pointing to ID, guys. Now on this stack, on stack, what do you have? Initially you have to keep 0 only. This is the initial configuration of the stack, 0. Now what you are going to look at, m of 0 comma ID. What is this? 0 comma ID, that is S5. So shift, remember the shift, what we have to do? Look at that. Second, I'm going to write the second step. What you are going to get, this is the shift, right? Shift action. What is the shift action? Did you remember that? What is the shift action? Quick. We push ID and along with the next state number, but we increment the pointer. So pointer pointing to now plus. Is that clear? Pointer pointing to the plus now. Now we have to look at m of 5 comma 5 is the top of the stack. Now we have to look at the plus 5 comma plus. Look at that 5 comma plus. That is R6. That is R6. Can you see that? R6. This is the reduction. This is the reduction. Reduced action. Now how to perform this reduction? You know that R6 means F derives ID. Everybody, F derives ID. So ID means one length. So 2 symbols we have to pop. 2 symbols we have to pop. We will pop 5 and ID, 2 times of ID. Then we push F. So third, I'm showing you parallelly to understand. This may take some time, it's okay. We'll go very slowly to understand this. We'll go very slowly to understand this. We pop. You have to remember the algorithm, guys. Pop 2 times of ID length. So popped it and push LHS, that is F. Everybody, now it's not over yet. Now you will understand. Okay, I have to look at 0 comma F. Then that entry comes here. 0 F. That entry is a 3. 3 is going to come here. And that is the third step of the reduced action. Third step of the reduced action. So that's a difficult all the time. Every time you perform reduced, there is a third step which takes some time. Because you pop 2 times of RHS, you push LHS, but then you need to push below LHS comma LHS combination of the table. Okay, so that's you require to remember. You require to remember. Now go on. Now look at the table. M of 3 is the top of the stack, and still plus is pointing. So better to delete this arrow. Keep arrow now at plus only. Now plus is your pointer is pointing to. Remember that. Your pointer pointing to plus. Okay, M of 3 comma plus. What is the action? Look at the table, guys. Look at the table. 3 comma plus 3 and then plus you have R4. R4 means again a reduction. Again reduction. What is reduced? R4 means this production. F is there, so 2 times of F, that is 2 symbols will pop. 2 symbols will be popped, that is a 3 and F, and we push LHS. So that's the 4th step. You will understand clearly. When I am going to do 4th, you will understand what I am doing. Okay, so you will have 0 and 2 you pop, and then LHS is a T you push. And now you need to look at the focus on 0 comma T. What is your entry? That you should go to 0 and T, that's a 2 should entry. The 2 is a new entry. That's a go to entry, guys. That is a go to entry. That's the 3rd step of the reduced action. Now we have to go back to 2 comma plus. 2 comma plus. Now start again. 2 comma plus. 2 comma plus is R2. That is R2. And it is a reduced action. And whenever reduced, you need to perform 3 things. Go to that R2. This is the R2 now. This is the R2, guys. That is 2 times of RHS. That 2 symbols will be popped. 2 symbols will be popped. And you push LHS. So that you will understand when you do it. So I am writing the 5th one so that you will understand what I am writing here. Slowly. 0 will be there. And I pop 2 symbols. Now LHS is a E. LHS is a E. I push it. Now below LHS is below LHS, guys. Look at below LHS. E and E. You need to look at in the table. 0 comma E. Now focus on 0 comma E. What is the entry? What is the entry? 0 comma E. That is a 1. So we are going to make an entry 1. Now again whole process will begin. Now algorithm will recurse. Now entry M of 1 comma plus. Now look at 1 comma plus is S6. Now after long time we got S6 shift action. What is a shift? You know it. What is a shift? Shift means, just go for the 7th step to 6th step to understand. That is, you will have, okay, let me write a 6th step from the bottom, guys, so that you can save our space. Okay, 6th step here. 0 is there, E is there, and 1 is there. Shift means the plus will be shifted, and then shift the next number, that is a 6. S6, 6. Okay, now after that, shift means the pointer now pointing to that ID. Sorry, is deleted completely. ID plus ID. Now in the input, we are pointing to now ID. Because we shifted, we incremented. And remember that there is always a dollar at the end of the input. That is our assumption. Okay, now we will start again process, guys. Quick. M of 6 comma ID. M of 6 comma ID. Now you have to look at shift is over, right? 6 comma ID. What is that? S5. So we are going to do the shift again. S5. And tell me how to do the shift. Same process. 7. Okay, now I need 0 and E and 1 plus 6. Now shift ID, push, and push next number 5. Now this is also incrementing, pointer incrementing to dollar. Now pointer pointing to dollar, guys. Pointer pointing dollar. Look at that, the top of the slide, what I'm doing. Next one, M of 5 comma dollar. Now look at that 5 comma dollar. The table will tell us what to do. R6. R6. What is the R6? Look at the production number. Production number. That is R6. F to ID. So 2 times of ID. So we need to pop that. That is 2 symbols. And push F. So that you will understand when you write next step. Zero, E and 1 plus 6. Now push LHS, that is F. Now look at who is below F. and f. Look at the table, 6 comma f, 6 comma f, that is 3, that is a 3. So 3 we are going to make an entry. That is the 7th step is over now. Now let's move on to the next one. M of 3 comma dollar, 3 comma dollar, 3 comma dollar. Now look at again, 3 comma dollar. What is that? 3 comma dollar is R4, R4. So we are going to do R4. What is the fourth production? T to F. So we pop 2 times of RHS, that is 2 into F length is 1. So 2 symbols will pop. And now left LHS is a T. We are going to push that. So do that 9th, you will understand what I am doing. 0, E, 1 plus 6. That LHS is a T, we push. Now look at who is the below LHS. 6 comma T we need to push. Who is that 6 comma T? 6 comma T. So this 9th combination we are going to get. 6 comma T is the 9. 9 we are going to push. Now we have to look at again M of 9 comma dollar. 9 comma dollar. 9 comma dollar. Quick. Look at how much time it takes, but this kind of algorithm may not be asked in competitive exam, but in interviews they may ask. 9 comma dollar. 9 comma dollar is R1. So I'm going to do R1. What is R1? 1 production. Production number 1. E derives E plus T. E plus T is the 3 length. So 3 into 2. So 3 times of E plus T length, that is a 6 length. So 6 symbols we are going to pop 1, 2, 3, 4, 5, 6. And push LHS, that is E. So I'm doing the 10th one. 0. Push LHS. Now 0 comma E, that we are going to look at in the table, and we will push that. 0 comma E. Look at guys. 0 comma E. 1, 1. So 1 we push. Now look at your table. M of 1 comma dollar is going to be accepting. Now it's going to accept. That's what, there is no syntax error. Other than the accept, if you go to the blank, then it is syntax error. Right? The remaining blanks, that all the blank entries correspond to error. Other than the accept, if you end up with any blank entry, then it will become an error. So this is how the LR parsing happens, guys. That means the ID plus ID is syntactically correct. That means your program has no syntax error. Okay, I hope you understood the concept how to perform the shift and reduction. To understand the shift, you must remember these 2 steps. Whenever you encounter with shift action and push your input, this is the first one, push input and then push this n number, right? Push next number. And when you perform the reduction, and guys, pop 2 times of this alpha and push LHS and also push the below x comma x on the table, whatever you have it. Okay, so these are the 3 steps of the reduced action. Now today what we have understood, guys, table construction, LR parsing algorithm. Next we are going to see what is the operator precedence parsing and how the precedence rules are going to be built for any programming language. That operator grammars are going to help us. And we know that multiplication has more precedence, plus has less precedence. Because C programming language following, but what is that following? Because compiler built that way, so that programming languages follows the same way. So operator grammars allows us to build the precedence rules of programming languages of operators. Okay, so tomorrow, next class, I'm going to talk about the operator precedence grammars and relations. Okay, see you guys till the next class. You may follow me, that is unacademy.com/DEVALIVE, and you will have n number of classes on my profile. Please learn, and we have very good educators on this platform. Follow everybody's class, whichever you are enjoying. And thank you so much, guys, and do not forget to like the session. Also, please share and subscribe to this channel. Thank you so much. And remember, DEVALIVE is my referral code. You can refer your friends or you can join yourself, and see you guys.